My area of expertise is sustainable design in architecture, and mostly what I do is try and research ways that we can build sustainably or build with minimal impact on the biosphere. And at Cornell specifically, I'm largely focused on the intersection of computation or modern computational environments and what that means in an architectural design process and how we can bring to bear advanced technologies on this particular problem. So my main research focus is probably in two places, one of which is I do a lot of work in building simulation, which is to say we want to know before we build a building how much energy it's going to use, which sounds like kind of a simple question, but is actually extremely difficult. And one of the things that's happened is that because building simulation is so difficult right now, it's mostly done by engineers. It's not done by architects, and it's not part of a design process. It's part of an engineering process that happens after we design buildings. So working with Don Greenberg, especially in computer graphics, with people in mechanical engineering like Lance Collins, we've been building advanced building simulation technologies that essentially enable us to simulate buildings at early design stage periods really fast. So for example, you normally would take hours and even days to do a proper thermal simulation of a building, but using parallel computing, using a cluster, for example, we can now cut that simulation time by 2 orders of magnitude. We're also building interfaces that make the way that you interact with the building simulation useful to you in a design process. So for example, you can really look at it and see your building and see how it's losing heat, see where it's using energy. And that's very important because the design process is always visual. It's not about looking at tabular numbers. And then the other thing we use it for is for predicative analysis. So normally what people would do is they'd analyze a building and it would give them a number, like this is how much energy you're using, but it doesn't really tell you what to do. And one of the things we do is we spawn thousands, literally, of simulations, parametric simulations, that simulate how your building might change, how you might change your design, and what impacts that would have on its ecological footprint, on its carbon usage. And then we develop what we would call a spline surface, which is essentially a probabilistic space that tells us how performance varies as different variables vary. And we do this very fast over a cluster. So actually, just a couple days ago, we managed to run 10,000 simulations in 3 days, which was, I think, way beyond a world record. Must be. I'm not sure. The other thing I do is I look at other kinds of technological applications. So I'm really interested in how can we integrate devices which produce clean energy into building skins. And I'm working on a project with mechanical engineering with Frank Moon, in mechanical engineering, Hod Lipson, Ephraim Garcia, where we're actually looking at incorporating wind power devices into building skins and architectural elements. But what's interesting is that we're looking at devices that can function at lower wind speeds and in turbulent wind flow, and these aren't turbines. So they don't rotate. What they do is they vibrate, because the vibration, using sort of chaos theory and how vortices form, the vibration can be translated through especially piezoelectrics directly into AC current. And so hopefully by the end of this semester we'll have a full prototype of a wind concentrating device that's essentially populated with all these little, they look a little bit like those lollipops you made when you were a kid when you put a popsicle stick in an ice cube, but they're piezoelectric arms, and as the things vibrate, they actually generate electricity. And that's an ongoing research project which has been funded by Cornell Center for Sustainable Futures, which is also funding other projects of mine. And again, the idea is, how do we think about this whole question of holistic sustainable building? And those are my main areas of research. And I'm also an architect and have a practice here in Ithaca, and we build, mostly at this point, we're building very low energy housing. And hopefully that's something that we work on as a practice, but also experimentally with our graduate students, with our students. And the idea is to figure out some of these things we work on in research, how do we actually put them into practice in the real world? And we're very interested in making these things real and not just having them be theoretical. So in the end, the goal fundamentally is to sort of change, at some level, how we understand the process through which we design things and how we integrate, both in terms of research, in terms of interdisciplinary research, and in terms of literal hardware and technology, how we integrate these things into the universe of sort of building technology, which in general tends to be fairly conservative. So at some level, we have our work cut out for us. But it's an interesting, it's certainly an interesting journey to try and do it.